Hey guys, welcome to Section 4, Chapter 11 of the Algebra 1 program. And in this section, we're going to learn how to perform some of the basic operations using terms with radicals. So something is going to be very similar in these types of operations that you've seen before with variables. So remember before, we could add terms with the same variable and we would simply just add how many we had, right? We had to be really careful though that the terms looked exactly the same in terms of the variable and the exponent. So we could not add something like 2x squared plus x and get like 3x squared, right? The terms had to match variable and exponent. And the same thing is going to be true with these radicals. So when I have the same number underneath the radical, like for example, if I have 3 square root of 7 plus 5 square root of 7, then I'm free to add the numbers outside and keep the radical, the number underneath the radical, the same. Remember we learned last time that the only way a number can get out from underneath the radical is if it has a pair. That's kind of like the magical cure to get out from underneath the radical. So otherwise we treat it like a variable. You're just going to bring it along for the ride. But in order for us to be able to perform an operation like addition, this number has to be the same in all of the terms. All right, so let's do another one. Like let's say if I have 15 square root of 3 minus 6 square root of 3, because the numbers underneath the radical are the same, then I'm able to perform the operation on the numbers outside. 15 take away 6, which is 9, and then leave the radical term the way that it is, right? You have to bring it along. You can't leave it behind or do anything with it unless you have a matching pair. Okay, so if you're given an expression and the number underneath the radical matches, you're good to go. But sometimes that's not always going to be the case. So for example, if I had something like the square root of 45 plus 2 square roots of 5. Now look, I have a 45 and a 5. I don't match. However, if I simplified square roots of 45, then I might get a match and be able to do an addition. So we're going to use that technique we learned last time. We're going to break this down to primes and see if we can simplify it. So there's my pair. I can pull that 3 out and leave that 5 underneath. Remember, he doesn't have a partner. And now the square root of 45 is rewritten as 3 square roots of 5 plus 2 square roots of 5. Now I can perform the addition here, leaving that square root the same. Okay, so for most of these, what you're going to do is either have to multiply initially and then simplify before you're going to be able to add or subtract. Okay, so what if I had the square root of 28 plus the square root of 63? Well, now I really don't match, right? So there's really nothing I can do until I simplify both of them. So I'm going to break down 28 to 7 and 4, and 4 is going to break down to 2 and 2. There's a pair. I can pull him out. However, 7 is lonely and has no partner, so he's going to stay underneath. And then for the 63, I'm going to do the same thing. I'm going to break this down to primes. He's got a pair, so I can pull out that 3. However, look at this. 7 is lonely. He's all by himself and he has to stay. All right, now I have matching numbers underneath the radical, so I can perform the operation for the numbers outside of the radical and get 5 square roots of 7. All right, hopefully you don't think that's too bad. Let's do one more like that. What if I have 9 square root of 2 minus the square root of 50? All right, 2 looks pretty basic and prime already, so let's work on the 50. I can break him down to 25 and 2, and then to 5 and 5. There's a pair. I can pull him out, but 2 is lone. He's lonely, so he stays underneath. Now I can bring down the rest of this problem, and I can perform the operation on the outside here, because I have matching numbers underneath the radical. All right, Now, what happens if you have a number out front first? What if we have something like 4 square roots of 2 times 2 plus 2 root 3? Well, we're going to use that distributive property. So if you have a number outside, even if it has a radical as part of the term, we're still going to distribute. And remember, everything on the outside of the radical has to stay on the outside, and everything underneath has to stay underneath unless we do something specific to get it out. So in this case, 4 is going to be multiplied times 2 to give me the 8 on the outside. The radical 2 stays because there's no number underneath the radical there to be multiplied to. All right, similarly, in the second term, I'm going to take this 4 and multiply it times the 2. They're both on the outside, so I get 8. And then the numbers underneath the radical can be multiplied together. So 2 times 3, which is 6. But remember, they're underneath the radical. They have to stay there. All right, in this case, we could try to break down 6, but of course, I'm not going to find any matching pair. So as uncomfortable as it makes me, in this case, this is our simplified form. Okay, so sometimes you won't be able to reduce it to a single term. Sometimes it's going to be more than one term like this, and that's okay. All right, let's do another one like that. What if I have 3 times 8 square root of 3 minus 7 square root of 2? All right, so numbers on the outside get to be matched. Only things underneath the radical get to be multiplied. So this is going to give me 24 root 3. And then, of course, here I'm going to multiply the 3 times the 7, give me 21 root 2. Nothing matches underneath that radical, and nothing is being multiplied underneath the radical, so it's got to stay there. All right, and then there's one other term. We're going to take that FOILed expression that you learned, remember, first, outside, inside, last, and we're going to apply it to terms with radicals. Can you believe it? Okay, so what if we have 2 square root of 3 plus square root of 2 times the square root of 3 minus 5 square root of 2. All right, when you have two sets of parentheses like this, you have got to FOIL in order to multiply this correctly. So be careful, go slow. Grab your first terms. So anything on the outside multiplies on the outside. He doesn't have a partner. Everything on the inside is going to get multiplied. So that square root 3 times square root 3 is going to give me a square root of 9. All right, now my outside terms. Outside 2 and outside negative 5 is going to give me a negative 10. And then what's underneath the radical will be multiplied together, giving me the square root of 6. All right, now my inside terms. There's no numbers on the outside, so I can just multiply the two numbers underneath the radical to give me 6. And then finally, I'm going to do these last terms. Negative 5 has a 1, right, to multiply with, so he just stays negative 5. And then the two numbers underneath the radical are going to be multiplied times 4. Okay, so now if you look, these middle terms can be added or subtracted, as the operation tells us, because they have the same number underneath the radical. So this is simply just going to be negative 9 square root of 6, right? Because this is a 1, so this is negative 10 plus 1, which is negative 9. All right, but look at this term. We know what the square root of 9 is. It's 3. So we can take care of that square root by actually just taking the square root of 9 and getting 3, which is going to give me a 6. Here, I'm going to keep this middle term here. And similarly here, the square root of 4 is 2. So now I can multiply those numbers because I've pulled them out of the square root and add them to my expression. Now I'm going to be able to combine these first and third terms and get negative 4 minus 9 square root of 6 as my final answer. Again, there's no matching term with the square root of 6, so he's got to stay there just the way that he is. All right, let's do another one like that. Don't freak out on me. It's all good. All right, what if you had something like 3 root 3 plus 4 quantity squared? Okay, remember that this means 3 root 3 plus 4 times 3 root 3 plus 4. And now we're going to FOIL. All right, first terms. 3 and 3 on the outside is going to give me 9. 3 and 3 underneath the radical here is going to give me a 9. Now I'm going to do my outside terms. There's a 4 times 3, going to give me 12 on the outside, but nobody under a radical to do anything with there. Sorry, that should be a plus. Okay, now my inside terms have another 12 root 3, right? Because I have the 4 and the 3 to be multiplied together, and then the radical term. And then my last terms, 4 times 4, which is just 16. Okay, so the middle terms are going to be able to add together. They're going to have the same radical. 16 here on the end can just pull down. But the square root of 9 is 3, so I can multiply that together and then be able to add these last two numbers. So when I add my first and 3 numbers, I'm going to get 43 plus 24 root 3. And that is going to be my answer. Okay, you guys, hopefully this is a nice way to end out the course. This isn't overly complicated. There are more examples in your book. So when you're ready, go ahead and finish up your notes, read through the examples, and begin your assignment.